Okay, I am having a bit of a nightmare here because this some noise came out in the two times that I recorded this, so I'm recording again, tested it, and seems to be okay now. So let's add a few more points to this idea of human ecology, where it's the idea of how humans live within the environment and interact with the environment. We looked at this, so we will put some more details on these adaptations that happened along the way and what the outcome was in terms of human evolution. So let's start here in terms of time. 6 to 2 million years ago, bipedal walking and tree climbing was a major evolutionary change, which obviously was important for versatile movement in wooded and open environments. And the big change that happened there was that potentially because Australia moved forward and northward and closed the direct link between the Indian and Pacific Oceans, climate changed, El Nino changed. If you don't know what El Nino is, you can look at my other courses. And this aridified East Africa, which was a lush green forest with lots of food and hiding places, safe habitats and so on. But when it changed and got aridified and became savannas and grasslands, species had to run further and to avoid predation or attacks and to walk further to find food and so on. So this presumably led to bipedalism. Our ancestors were quadrupedal, if you look at chimpanzees and gorillas now, for example, or the monkeys. And the change of bipedalism would have also changed the connection between the spine and the cranium, and later on the range of foods got increased, so improved access to diverse food happened because of this movement, which over time, especially with controlling fire and cooked food, would have reduced the length of the gut, would have changed the jaw muscle structure, allowed the cranium to grow, brain to expand, and so on. All hypotheses. Simple stone flaking, so changes in the hand, fingers, opposable thumb, skills, extensive carrying of stones and food by 2 million years ago, pronounced elongation of legs, so the body structure changed. Initial advances in stone technology, humans became better hunters by building spears. Humans are very good at throwing, they are the best at throwing far, and they have the most endurance in terms of walking and running as well. A million years to 100,000 years ago, most rapid increase in relative brain size happened. By 800,000 to 400,000 years ago, controlling fire and building shelters changed the diets quite completely. Food sharing at home basis enhanced social memory and buffering of uncertainty, so saving food for uncertain times. And exchanging resources over long distances. Homo sapiens came along, to the best of our knowledge so far, around 200,000, about 300,000 years ago. Then came enhanced symbolic behavior. Much later came cave paintings, music, languages, etc. And 100,000 years ago to the present, increased cultural diversity and technological innovation. Of course, that has expanded the range of adaptive options, and especially with the Industrial Revolution, science and technology. The question is, are we now completely immune? Are we in control of nature? But if you look at COVID, the pandemic that's happening as I'm recording this in June 2021, it's not at all clear that we are so safe after all, right? The pandemic is still going on. It's not done. When will it end? What will be the net outcome? It's not clear, right? So briefly, schematically, we went through warm, moist, and cold, dry periods. Adaptive versatility led to extinction of many species, including the Neanderthals just 25,000 years ago or so. Migrations happened because of climate change, and they were following habitat changes. Human ecology and versatility has also increased in terms of adaptation that we looked at. And these are the simple schematics of evidence-based migration sites and timing. So Hader, Homo, Turkana, Olduvai going from 2.36 to 1.85 million years ago, to different climates, and of course faraway places, warm tropical to colder high latitude places, included adaptations in skin color, diets, food production, types of foods, and so on, clothing, etc. And this is just a graphic artist's rendition of Homo neanderthalensis, which went extinct around 25,000 years ago. Homo heidelbergensis, you have to look it up, I can't even read it here, and Homo erectus. So the Homo lineage was followed the older ones, Ardipithecus, Australopithecus, Kenyanthropus, and so on, which extinct. Some of them coexisted. For example, Neanderthals have left a lot of genes in us, and there is some research that argues that maybe it's the Neanderthal gene that's making us vulnerable to coronavirus, for example. Zooming in closer, the modern human beings as we are now evolved in the last 12,000 or so years ago, over 12,000 or so years since the end of the last ice age. And you can see that compared to the 1961 to 1990 period, the temperature range has remained fairly mild compared to the previous ranges we saw. And there have been historical human ecological interactions that have resulted in Holocene climatic optimum phases 1 and 2. Sahara went through green lush times and cool dry periods. Drought and cool in the eastern Mediterranean, Roman warm periods that we already talked about in the last podcast, medieval warm period over Europe. There was acute cooling around 536 CE. Medieval warm period led Vikings to colonize Greenland and make it all the way to North Canada, and agriculture on Greenland, and then came volcanic eruptions, solar activities that led to Little Ice Age. And then we are in this boom period of burning fossil fuels and increasing greenhouse gases and heading into this la-la land in terms of warming. It's not just the temperature change, it is the rate at which temperatures are changing that will determine human ecology, food, water, air, health, right? And our adaptation in terms of even science and technology. It has been associated with energy consumption. Daily energy use per person in megajoules has gone super exponential since the Industrial Revolution, James Watt modified the steam engine, coal burning, and so on. And now all activities are focused on renewables and trying to reduce greenhouse gas emissions, which is obviously not been reducing at all. So bringing back to human health, if we look at a couple of examples, for example, index of malaria transmission February to May in Solomon Islands, there is a niche in which the pathogens survive, in which humans are vulnerable, human activities change, temperature, rainfall change. So January maximum temperature versus malaria transmission shows a peak somewhere here and drops off at higher temperatures and drops off at lower temperatures. So the pathogen ecology, human interactions, mosquito populations, vegetation, everything is going to matter. The other example is number of cases of diarrhea per month in Suva, Fiji. So you can see at lower rainfall rates here in millimeters 1 month previously, increases the diarrhea quite fast, and increases in the other direction when there is extreme rainfall as well, with this minimum in the middle. So this is what the total ecology of human health outcome is. What is happening to the pathogen? What is happening to human activity? What is happening to the habitats? What is happening to human diet, interactions, etc., that determine the disease outcomes. So that's what the course is going to start with in terms of looking at the philosophical approach of human ecology, and then go to the more traditional approach of looking at individual health outcomes and vulnerabilities and predictions for these actions to warn people about malaria, encephalitis, meningitis, cholera, and dengue, etc. Okay, so we will continue along those lines. Hopefully this podcast is recorded properly Otherwise, I have to re-record it again for the 4th time.